Ever wondered what makes something alive? It's a simple enough question with a very profound and difficult answer. Join me next as we look to answer the question, what is life? And how would we know if we found it? Stay tuned. If you saw something new, something you haven't seen before, how could you even tell if it's alive? This is a question of much debate. At a minimum, scientists can agree on the following set. Reproduction. A living organism must be able to reproduce, or it quickly dies off, along with any chance of continuing its future. Metabolism, or put simply, taking in energy in the form of food and using it to do work, that is, to find more food, to reproduce, or to affect its environment. The elimination of waste, either solid or liquid, or even in the form of heat. According to thermodynamics, the conversion of food to energy is not 100% efficient, so some waste heat is created in the process. Is this a perfect definition? Absolutely not. You can probably think of some things that satisfy this criteria that are not alive, such as fire, viruses, even computer viruses share some of these characteristics of life. Think about it. Fire reproduces by spark. Viruses reproduce by cell division. And computer viruses spread by, many different ways. Fire also consumes things, takes in energy, and it turns it to ash. Viruses often kill their hosts, and computer viruses often take data down with them. Each of these things also can demonstrate the characteristics of life. So NASA decided to take on the question of whether or not there is life, or ever has been life, on Mars. So in 1976, they sent the Viking lander to Mars. They actually sent two, and each had a robotic arm that extended from the spacecraft body to scoop up soil. This is an actual image from one of the Viking landers. It took soil from around the spacecraft and placed it into an onboard lab and ran experiments. These experiments looked for signs of metabolism. The experiment produced surprising and contradictory results that are still being studied over 40 years later. This experiment was called the labeled release experiment. It collected samples of Martian soil, injected them with a drop of nutrients or food, and then monitored the air above the soil for metabolic products, specifically CO2 and methane. To be sure that it was not going to get false positives or false negatives, researchers first tested the experiment on Earth. They used the same protocols on a wide variety of terrestrial soils from harsh environments, like Death Valley and Antarctica, two of the harshest climates on Earth. In each case, the experiments tested positive for life. Then, the researchers heated the samples to kill all life forms, and then retested. In each case, as expected, the experiments tested negative. To further confirm that the experimental procedure would not produce false positives, the researchers tested it on soils known to be sterile. Again, negative results, as expected, were observed. The Viking landers were commanded to extend their arm, to scoop up samples, and drop those samples into an onboard lab for testing. It came as a huge surprise when both Viking landers, located 4,000 miles apart, collected soil that tested positive for metabolism. In addition, it seemed that whatever was doing the metabolizing was relatively fragile. Metabolic activity was significantly reduced when heating the sample to 50 degrees Celsius, and completely absent when storing the soil in the dark for 2 months at 10 degrees Celsius. These results provides some of the strongest evidence yet that the soil contained Martian life. The consensus, of course, from most scientists in the years since then has been that there was something in the soil mimicking life, but it wasn't life itself. As a result, none of the following missions over the next few decades carried any life-detecting experiments like the Viking did. Instead, they have focused on past habitability. Was there life? Maybe. Since then, more intrigue has been introduced. In 2014, when the Mars Science Laboratory Curiosity rover detected the presence of organic molecules on Mars for the first time. Organic molecules are fleeting. They're broken down by the environment unless replenished. Biological processes are one way they are created. In fact, more than 90% of the methane in Earth's atmosphere is generated by microbes and other organisms, living organisms. Taken together, these results seem to indicate a strong case for life on Mars. Of course, some people are convinced there's a cover-up, but that's a subject for a different time.
There's never a wrong time to enjoy a nice cold Diet Pepsi. It's the Diet Cola.
Okay, everyone, focus. Prepare to enter the atmosphere. Sweden, let's get this thing onto the ground.
Okay, we have parachute online.
Okay, inflate airbags. Open. Has it been found? Camera off.
Should have a picture right now.
Thank you, Germany. Okay, there's more to do. Now, if there is life, the Dutch will find it. Wait. What is he doing? What is that?
Now we wait.